2.4b is in Bravo. I am on example number 6, page 154, and it's just asking us to find the solution set, but I'll probably graph it just so you can keep up on how to do that. All right, so what we're doing, we're just trying to find the y. So we're going to add 3 to both sides. So negative 2y less than or equal to 10. Now we're going to divide by what? A negative. So when we divide by that negative, the sign switches. So instead of it being a positive number over here, it switched. Now it's a negative number. So there's our answer. If I'm going to graph this, again, I put 0 there. I put the negative 5 on there. And because it's greater than or equal, it's a squared. And then it goes to the left or right into infinity because the number is bigger than negative 5. If you were to use interval notation, because it includes negative 5, we put the bracket and positive infinity. That looks like a little bit better infinity than when I'm trying to do that. So anyway, so positive infinity. Some people will put a plus sign there, but it doesn't really matter. Okay, so that's example 6. Let's jump up to example number 7. And they're just giving you various ways of doing these problems as they get a little bit more complicated, although, you know, the method is the exact same. So, of course, we're going to do the distributive property first. Combine like terms. Okay, nothing really weird here yet. I'm going to add 3x to both sides. So I get rid of everything over there. Keep going. I'm going to add 12 to both sides. So 2x is less than or equal to 12. X is less than or equal to 6 because I divide both sides by 2. So notice our signs did not change because there was no dividing or multiplying by a negative number. You could have multiplied or divided by a negative number. They did it on page 155 when they solved this, but we didn't. We did a different method, or not different method, but a different option to where we didn't have a lot of negative numbers that were moving back and forth. So because we didn't multiply or divide by a negative, we didn't have to switch the sign around. Okay, so example 8. And it's asking us to solve for y. So we're not coming up with what x and y equals. All we're doing is taking everything that's on the left and except the y and moving it all to the right. So I'm going to subtract 2x. So I get negative 3y is less than 6 minus 2x, or negative 2x plus 6, either way. Now I'm going to divide both sides by a negative 3. Because I divided both sides by negative 3, this switches around. Okay, so I'm going to see, maybe I can simplify this a little bit. And one of the ways that we simplify, and this is old stuff, is we put this negative 3 under each term. I put negative 3 there. So these two negatives together make that positive. And the reason we separate that is because sometimes we can reduce. So right here, we've got a negative 2. And then we've got 2x over 3. So that can be written that way, or it can be written as 2x over 3 minus 2. So just all I did was flip those around. And that's what you've got. I mean, you're not gonna graph this, at least at this time. So that's pretty much it. Let's go ahead and do example 9 and call it good. So example number 9 throws students a lot of times because we're dealing with inequalities, but let's look at it one piece at a time. The sum of two consecutive odd integers. All right, so consecutive means they follow one after the other. So consecutive integers are like 2, 3, 4, 5, etc. Consecutive odd integers would be the order, but only the odd numbers. So what they're saying is the sum of two consecutive odd integers is at most 28. So when we add this number and this number, they're saying we want to get 28 or a number less than 28. So we can add two numbers together and get 28, but we can't get bigger than 28. We can only be 28 or smaller. So it says, what are the possibilities for the first of the two integers? They're not asking for the two integers. They're just asking for the first one. So let me, first of all, here's the answer. The answer is 13 and 15. Because 13 plus 15 is 28. These are consecutive odd integers. And so the answer they're looking for is the first number, which is 13. So how do they get that? They're taking their first number, adding their next number, and getting a number less than, oh, that's a terrible less than sign. They're getting a number less than or equal to 28. So that when I add these two numbers together, I can get 28, and I can also pick numbers that would give me less than 28. So let's figure out what these numbers are that go here. Well, the first number, I'm going to use x. So x plus another number is less than or equal to 28. So how do I label this number? Well, how did I get from 3 to 5? What did I add to 3 to get 5? I added 2. What did I add to 13 to get 15? 2. What do I add to this to get the next one? Also 2. Now, I'm going to subtract 2 from both sides. Notice I subtracted. I didn't divide or multiply, so I didn't have to change the sign. Divide by 2. We're dividing by positive, so that's how we got 13. Would the numbers 9 and 11 work? 9 plus 11 is 20. Is that less than 28? Yes, it is. So 9 and 11 work. So what we're saying is any two numbers that you add up to get a number equal to 28, like in 13 and 15, or less than 28, is going to work. So if this were a 3, this would have to be a 5, and that gives me 8, which is less than or equal to 28. So what we found here with our 13 is the smallest number that the largest number that we could put in there. Because if we put a larger number than 9, like 15, or a larger number than 13, such as 15, we have to add 17 to that, which would give us 32. So make sure you understand that, and that is it for 2.4.